Scientific notation is a shorthand for writing either really big numbers or really small numbers in more of a compact form. So, shorthand notation for writing really big or small numbers. So the idea for this is most really big numbers or really small numbers have a lot of zeros with them. And we can replace those zeros by using powers of 10. So the idea here is, let's just take a look what happens. If I said 4 times 10, of course that is 40, right? If I had 4 times 100, which I can write 100 as 4 squared, that's really 4 times 100 is 400. Notice what's happening to our decimal place, right? Our decimal place originally, our decimal place originally for the 4 was right here. When we multiplied by 10, the decimal place moved 1 to the right. When we multiplied by 100, it moved 2 to the right. So, of course, we did 4 times 1,000, which would be 4 times 10 to the third. Of course, is 4,000. It moved the decimal over 3 places. So you see, when we multiply by powers of 10, all we're doing is we're shifting the decimal place. Now the same works for division, but it's going to be a little bit weird here. If I said 4 divided by 10, that would be, well, 4/10. Now, I'm going to erase this just real quick. There's a way that we can write a division slightly differently than we've ever seen before. Since that's really 10 to the first power and we're dividing by it, we actually can write that as 10 to the negative 1 power. That just says the negative means where you're dividing by it. So 4 divided by 10 is 4/10. 4 divided by 100, which we could write as 4 times 10 to the negative 2, because 100 is 10 squared, would be, well, 4/100. Notice again what's happening to our decimal place. Our decimal place was here, but when we multiply by 10 to the negative 1, it moved to the left 1. 10 to the negative 2 moved to the left twice. And of course, if we did this as 1,000, which again we write as 4 times 10 to the negative 3, that would move our decimal 3 places over, right? It was here, move it over 1, 2, 3. So it was here 1, 2, 3 places. Now by doing this, we can actually take a number that has a lot of zeros in it and rewrite it as multiplying by powers of 10. The only difference that we're going to do here is instead of using the dot notation, this is the only place from now on that you're ever going to use the x for multiplication again. So instead of writing this like 4 times 10 to the third like that, we're going to write this as 4 times 10 to the third. All right, so let's take a look at this. We're going to need to be able to start out with scientific notation, start with a number like this and expand it out. And we're going to need to take numbers that didn't start out in scientific notation and write them using scientific notation. So let's start first by expand the number. So if I gave you 2.3 times 10 to the 4th. All right, we saw when we multiply by a power of 10, and it's positive, the number is getting bigger. So that means I'm going to start with this decimal that was right here, and I'll put it in red real quick, but I'm going to erase it here in a second. We need to move that decimal 4 places to the right. So there's 1 place, 2, 3, 4. So that's where the decimal place needs to end up. Now all these spots that I counted over now need zeros. Okay, so 2.3 times 10 to the 4th is really 23,000. So if I said it's 1.7 times 10 to the 5th, see if you can write that out in expanded form. All right, so what do we need to do? We need to move this decimal 5 places to the right. So again, I'm going to put this here just for a second, and I'm going to erase it. That's where the decimal was. I need to go over 1, 2, 3, 4, 5, and that's where it's going to be. Which means I need to put in 4 zeros. So that gives me 170,000. All right, so going the other way, what if I said 5.82 times 10 to the negative 4? Now this time, since we're technically dividing by powers of 10, this number is going to get smaller. So now we're going to move our decimal to the left. So since we're going to move to the left, again, I'm going to start like this, the 5 point. That's where the decimal place was. Since we're dividing, it gets smaller, so I move it over 1, 2, 3, 4. So that's where the new decimal place is, which means we need to put in these zeros. So I get 0.000582. Now again, the 0 out front right there is optional. You can put it there if you would like. All right, let me give you all one of these to try. What if I said 6.2 times 10 to the negative 3? See if you can expand that number out. All right, if you're back, let's see how you did. Again, remember these red decimal places don't belong here. It's just kind of showing you where it was. So we're going to start out with our 6.2. Since that's a negative exponent, this is getting smaller, so I need to move it 3 places. 1, 2, 3 places. That's where the decimal is going to end up, which means I need to put 2 zeros in there. 0, 0, 6, 2. Again, the 0 out front is optional. Okay, so that's how you take a number that's in scientific notation and write it back as the original number. But how do we actually write a number in scientific notation? So we're going to start with a number that kind of looks like this. Let's go 2, 3, 0, 0, 0, 0, 0. So 2,300,000. How do we write this as a scientific notation? All right, we need 2 rules. We know we need a number out front here, and then we're going to multiply by 10 to the something here. So the 2 things we need is what number goes out here and what exponent goes up here for our 10. All right, first off, the number that goes out front has to fall between it's always going to be 1 point something to 9 point something. Okay, so what do I mean by this? When we see our scientific notation, notice like this example, we have 5 point something or 6 point something. So the number that goes out front is always got to fall between 1 point something to 9 point something. So you can never have a 2-digit number out front. So basically what you're going to do is you put the decimal between the first 2 numbers here. So our number's actually going to go the decimal between the 2 and the 3. Now the idea is we're going to be able to replace all these zeros with a power of 10. Okay, what you do is take a look where the decimal is now. How many places did it take to get it there? 1, 2, 3, 4, 5, 6, because that's where it ended up. So it took us 6 places there. By moving this decimal this way, I made this number smaller, right? It was 2,300,000. I wrote it as 2.3. So to get it back big again, I need to multiply by a big power of 10, which was 10 to the 1, 2, 3, 4, 5, 6 places. And you can see, expand this back out, you should get to our original number. Okay, let's try another one of these. Let's say if I had 6, 2, 0, 6, 2, 5, 0, 0, 0, 0, 0. So 62,500,000. If we were to write this in scientific notation, again, I want to put the decimal between the 6 and the 2, and basically drop all the zeros now, times 10 to the what? Well, how many places did I have to move the decimal point? It started here and ended there. So it's 1, 2, 3, 4, 5, 6, 7 places. So to get it back to be there, I have to do 6.25 times 10 to the 7th. Now it works the same way when you move the decimal place the other direction. So if I said 0.000518, Again, I want the decimal between the first two numbers, so I'm gonna write that as 5.18, and then get rid of all the zeros. I'm gonna multiply by a power of 10. Now notice I took a really small number and made it bigger by making the decimal place go to the right. So I'm gonna have to multiply by power of 10 to the negative something to get it back. Again, how many places did I have to move my decimal to get it to where I put it? 1, 2, 3, 4 places. So this would be 5.8 times 10 to the negative 4. All right, let's see how you do here. Give you all one of these. 0, 4, 2, 7, 9. Okay. 0.000279. Hit pause and see if you can write this number in scientific notation. All right, so if you're back, we're going to move the decimal between the 2 and the 7. That makes it 2.79 times 10 to the something. By moving the decimal, I made the original number bigger, so to get it back to where it was, I'm going to have to make it smaller, so I have to divide by 10. And how many places did I move that decimal? 1, 2, 3, 4, 5 places. So I'm going to have to divide by 10 to the 5th. All right, scientific notation, very, very useful. You're going to see this in a lot of your science classes because, well, in science you deal with some really big numbers, like, you know, how far is it from here to the next star? Or really, really small numbers, like in a biology class, you know, how wide is a human blood cell? It's going to be a really, really small number. So it's very helpful to be able to write really big numbers or really small numbers using scientific notation.